All right, stabilizing selection. In this pattern of natural selection, the average traits are what you see most of. Okay, now we have, I'm going to use the birth size of babies for humans. We have a lot of medical technology and stuff that helps us survive and helps moms and babies survive. But if you always notice, like the movies from back in the day, medieval times, you know, stuff like that, the mom often died in birth, different things like that happened. The baby didn't survive the birthing process. But now we have things that make it different. So thinking back, if we didn't have all these medical technologies and stuff, and you looked at the birth size of babies where they actually survived, it was within a certain range. Okay, so between 7, oops, let me go back here. Okay, between 7 to 8 pounds is where we find most babies being the best birth weight. Okay, and we don't have a nice even bell curve. It kind of focuses more in the averages, because babies born under 7 pounds were less likely to survive. They might not have had enough fat or nutrition to keep them alive, or long enough for the mother's breast milk to come in. All these different complications that could have come up if the baby was less than 7 pounds. Over here, being above 8 pounds. Well, if you're above 8 pounds, that could mean that you're too large, that you were more likely to get stuck in the birth canal. And if you're stuck in the birth canal, the baby could die due to lack of oxygen because the umbilical cord gets pinched. It could kill the mom, all these different things. So in this case, in stabilizing selection, the average gets favored, and you see less of the extremes. All right, the last type of selection in this pattern, here again is the original bell curve. So I'm going to go ahead and draw the beak sizes again. So here's smaller beaks, here's medium-sized beaks, and here's the large beaks. Okay, and the medium-sized beaks, that's the average of the trait. That's the best to have, and those are the ones that are more that are surviving. But then the environment changes, and in this case, let's say that all that's available now is really tiny small seeds and really large honking seeds. Well, if you're a bird with a smaller beak, you're going to probably be more successful at getting the smaller seeds and breaking them open and getting more food. If you're a bird with a larger beak, you're going to be more successful at getting the larger seeds cracked open and getting more food and nutrition. So we see actually a shift here in this case, where it's not good to have the average. And this is, even though this is where most of the birds were, now we see a shift. Having a smaller beak is more favored, so we start to see more and more birds with smaller beaks. Less birds with the average size beak, and more birds with the bigger beaks. So kind of looks like a roller coaster with disruptive selection. So the average, not good to be, it's better to be below average or above average in this case. All right, so big ideas here. Natural selection acts on phenotypes. However, the genotypes are important. The alleles that the individual carries are important because they determine the phenotypes. But overall, when it comes down to it, when it comes to natural selection, it's your phenotypes, your physical traits that help you survive. Okay, so looking at this species of birds here, they have different phenotypes. Okay. As a result of natural selection acting on phenotype, it affects gene pools though too. Okay, so in this bird's case here, let's say it's better to be the darker colored bird. The alleles that cause the red color here, if it's better to be this, over time, those alleles will basically start to disappear and change. That'll change the gene pool. So the alleles will actually start to disappear from the gene pool for the red color. And then that will definitely change the allele frequencies. We're going to see a higher frequency of the alleles for the black color than for the red color. Okay, so that is population genetics, and we'll go over it again in class and talk a little bit more about these ideas.